everyone. This paper is for JEE Advanced students. This is mock test paper 1 of JEE Advanced. So we are going to solve paper 1 now and paper 2 is going to come. Okay, how many mark this paper you need? Just let me know in the comment. Just now I'll create a video on that. Okay, fine. Let's get started with the first question. The black precipitate of X, which we are getting from B, and then B is reacted with sodium complex to give violet colored compound Y. Okay. An organic compound A reacts with dilute H2SO4 to give a colorless gas B, which smells like rotten egg. Okay. Change in oxidation state of Fe. That is the question. When reacts with B to give Y. Cool. So our main concern of this question is that only this part, the right side part, right? So what happens over here? What would be our B? A is reacting with dilute H2SO4 to give colorless gas B. B, which smells like rotten egg. Okay, so rotten egg, then that can be of H2S, sulfide, right? Sulfur compound. Why I am saying sulfur? Because with AgNO3 it is giving you black precipitate, right? So it can be a chances of sulfur. So with the sulfur compound with this sodium ion complex to produce violet colored complex. Do you remember sodium nitroprusside test, right? For the formation of violet color. So they are asking for the oxidation state difference. So if you know what is that violet colored compound, then only you can answer to this question. That is very simple. The ring is because of NOS, this complex, right? So here also you can see the oxidation state didn't change. So here and here the oxidation state remains the same. So answer to this question is 0. Moving on to the next question. Number of moles of acidified potassium dichromate required to oxidize 340 gram of gas B. Okay, so what is gas B over here? That is H2S. Okay, we have 340 grams of H2S and number of moles of acidified potassium dichromate they are asking. Okay, cool. So how we can go about this question is that acidified potassium dichromate, how it reacts with our sulfide. So you know the reaction, potassium dichromate or dichromate reacting with the famous ionic reaction. You can see that is S2 minus. I'm not writing the balanced form. Let me balance it in the end, which gives 2 chromium is there. Okay. 3 plus it will form 3 sulfide and 7 H2O. This side also 3 ES and 14 H plus. So people who would practice a lot from chapter 1, they must have across this question, this type of questions. Okay. So for 3 moles of S2, 1 mole of chromate is used. Correct. So for 10 moles of S2 minus, how many moles will be there? That you can easily calculate it. Right? 10 moles, how did I go 10 moles? Because of 340 gram is given over there. So sulfur, which is 32 and 2 hydrogens. So 340 by 34, which is 10. So for 10 moles, how many moles would be required? So 10 by 3, which is 3.33 moles of potassium dichromate is needed. Right? 3.33. So option A would be the right answer. Let's say this question. Total number of compounds from P to U, which can give yellow precipitate when reacts with sodium OI. Right? So what is that reaction? Which is nothing but our iodoform reaction. So what is the criteria to show positive for iodoform reaction? Where CH3 group must be attached with the functional group. Directly attached with our functional group. Right, acetone. or acetaldehyde, like that. Okay, let's check. So let's see this reaction in detail, because this is a comprehension type of question. So we have another question based on this diagram as well. So let's see this. So first we have CH3Cn. CH3Cn, which is reacted with H3O plus. That is hydrolysis, right? Which will give you acetic acid. Okay, cool. So then that is our P. Then this is reacted with lithium aluminum hydride and H2O to produce Q. So Q is nothing but our acetaldehyde or a lithium aluminum hydride strong oxidizing agent, so which will produce our ethanol, right? That is our Q. So Q is reacted with PBr3, so which is very simple. CH3CH2 Br will be formed. That is our R. So R, that is reacting with, there are two types of reaction undergoing with R. So let me take the first one where it involves S. Okay, so R with magnesium and S. So what is S? Yes, that is from our CH3 acetic acid. Okay, acetic acid. So what is the reagent given over here is that from acetic acid, SOCl2 and lithium aluminum, that is our organometallic compound, is given with H2. So first it will form CH3COCl, then that will give you CH3CHO. That is our S. Okay, and then H2. So magnesium with S and H2O. This R is forming CH3C, CH2CH3 from ethyl bromide, and then CHOH. So that is our T. And T is undergoing oxidation with sodium dichromate, right? That is giving us V. So oxidation, so which will produce CH3CHOH, means that will produce CO, CH2CH3. That is our V. Cool. So V is, so what is V? V is undergoing excess of ethyl magnesium bromide to produce U. Okay, so what U can be of, which is CH3, just deleting it. Okay, CH3, C again, here I am having the ethyl group and this side I am having ethyl group. So it may be look clumsy, but if you are following it without skipping it, it will be clear for you. Okay, that is our U. So what is the question asked over here? That is from P to U, which can have our yellow precipitate. Okay, so let's analyze. P, can it have our yellow precipitate? No, because it's nothing but our iodoform. No, iodoform is oxidation. So let's check. Then what about Q? It can give, so 1. And what about R? R is giving, R is bromide, so it can't give. And what about S? S can give. Then what about our T? T can also give. V can also give. U cannot. Did I miss anything? So answer to this question becomes 4. Then moving on, let's see this question which is related with the previous one. Total number of monochlorinated products obtained when compound W undergoes photochlorination. So first of all, what is compound W? Which is formed from our tertiary alcohol, isn't it? So which is undergoing our reaction with red phosphorus H. So which will produce our CH3 I with ET and ET. If that is undergoing the monochlorination or photochlorination, then what are the possibilities? The first possibility, it can give CH2. I mean that this part, that is 1. I'm writing those separately. Okay. Another possibility would be which is attached with here. So reminding I'm writing as such as ethyl. This is ethyl and this is also ethyl. Another possibility would be one of those ethyl group is getting that CH2 and CHCl, CH3, and another side ethyl will be there. Right? So that is one possibility. In here you can see this carbon becomes our chiral center. So this can exhibit D and L isomer. Okay. So any other possibilities do we have? It can give then another CH3 also, isn't it? So which will produce CH3, C ethyl, and then CH2, CH2Cl. So that is also our one possibility, where in that case this carbon becomes our chiral center. And here also this carbon, again it is also a chiral center, which makes 2 chiral center over here. So the possibility is 2 to the power 2, 4. And apart from that, 1, 2, here I am having 4, and this is 1 chiral center. So 2 here, I mean 3 and 4. So total the answer to this question is 8. Moving on to the next one. The unit cell is the smallest repeating G unit a crystal structure. The unit cell of the gold crystal is found X-ray diffraction to have a face center cubic unit structure. The side of the unit cell is found to be 0.400 nanometer. The density of gold is 2.0625 into 10 to the power 4 kilogram per meter cube. If the mass of one gold atom is X into 10 to the power minus 25 kilogram, then value of X will be. So that is our question. So we are just going to apply into formula. So volume, we can get it from our side of the unit cell, that is A cube, means that is a face center cubic. So which will be our 6.4 into 10 to the power minus 29 meter cube. Then they are asking for the mass. So mass, which is equal to density into volume. So the density is given that 2.0625 into 10 to the power 4, and the volume we found that is 6.4 into 10 to the power minus 29, which is equal to 1.32 into 10 to the power minus 24. Mass of one gold atom. Correct. So one gold atom they are asking, and for that we are going to divide it by 4 because of the cubic face centered cubic unit structure. Total atom accommodated, total atom that is having, that is 4. So divided by 4, which will give you 3.3 into 10 to the power minus 25. 3.3. So option A becomes your right answer. If the Avogadro constant Y into 10 to the power 23, then value of Y is, given the relative atomic mass of gold is 198.33. Okay, so Avogadro's constant, they are asking. So just a simple equation, relative atomic mass we know that is 198.33, right? And divided by our what we have found from the previous answer, that is 3.33 into 10 to the power 25, that is the mass of one gold atom. So I'm substituting over here. So 3.33 into 10 to the power minus 25 kilogram. I'm going to substitute it in grams, so it will be 22 grams. Right, okay. So where I'll get 6.01 into 10 to the power 23 as our answer, option B. Then this question, when the Gopal complex reacts with excess of ammonia, this is forming a complex then that is reacted with HCl added to form the complex X, which contains no H2O as the ligand and shows purple color. Okay, so 1 mole of X gives 2 mole of AgCl treated with the excess of AgNO3 solution. Then the formula and magnetic nature of it. Okay, here the important key to be noted is that 2 moles of AgCl is produced when we are treating it with AgNO3. We know that the ions outside the complex only will react. So outside the complex I must be having 2 Cl, right? So then only that can give you 2 moles of AgCl, right? So among these options, which is not having H2O, but I could write that as having Cl2 out of the coordination sphere. So which of these options would be right? If you are taking, here I am having 5 ammonia, right? There only I am adding HCl. Okay, so 5 ammonia complex I am taking, which is either B or D must be our answer. So I am writing it as a coordination complex, which is CONH3 5 times Cl. So while finding the oxidation state and the magnetic moment, you can see amine is a neutral ligand and then only we have Cl. So the Gopal oxidation state becomes 3 plus. So for 3 plus, so what would be our magnetic moment? That is paramagnetic or diamagnetic. So with Gopal it can, which is will have 3d6. With Gopal complex it acts as a strong field, so which can produce the diamagnetic compound, right? The next question is, it is an inner orbital octahedral complex. Yes, that is true. It is undergoing the pairing up. So it is an inner orbital octahedral complex. Complex show geometrical isomerism. No. This is an example of A5B type. So no chance. Then IUPAC name of this complex tetraamine dichlorido Gopal chloride. No. This is having 5 amine groups. So this is also false statement. Van factor of the complex is 2. So actually that is 3 because I am having 2 Cl and 1 complex. Okay, so this is becomes false. So answer to this question is only A. Then this question, P is undergoing ozonolysis to produce Q. Q is undergoing dilute NaOH and heat to produce our aldehyde, cyclic aldehyde, and then Q with osmium tetroxide producing S. S with R, it is giving again Q. Okay, identify the compounds S and R in the above reaction. Okay, so our clue is that only I'm having aldehyde over here. So we have to do the reverse retrosynthesis of this compound. Right? So the reversal, if I am taking, this is a alpha beta unsaturated aldehyde. Sorry, this is alpha and this is beta unsaturated aldehyde. So with dilute NaOH it has been formed. So it would be the possibility of I am having the aldol condensation reaction. So this is our Q. And Q, is formed from ozonolysis of P. So I'm doing reverse. So there must be a bond over here between two CHO group that must be broke to form Q. So I am having a structure like this with a double bond. Okay, so that is our P. Then P gives S. So with osmium tetroxide is famous for syn product. Okay, so it will produce S like this, right? Okay, this is our S. So S is giving Q by what? So S, that is having secondary alcohol. How that will give you Q? So let's take out the options as well. So yes, do we have found yet? Yes, yes. So either option A or option C would be our right answer. With PCC, will that give Q, or with the reagent is HiO4? PCC is a mild oxidizing agent, right? Which will give you primary alcohol to aldehyde, right? But in case of HiO4, periodic acid, so that will give you Q. This works great for our diol compounds, vicinal diols, right? Which will react with periodic acid to give 2 carbonyl compounds, 2 carbonyl containing. Okay, so answer to this question is option C. Correct statement about T is, so what is T? S is giving reacting with another aldehyde to produce T. Okay, let me take yes. So yes, reacting with CH3CHO in acidic medium to produce T. So what T can be of? This CH3CHO, it is just getting attached like this. Here I'm having 2 alcohols. So one with, okay, let's not, do we have to care about the stereo part? No. So let's not worry about that. So let me take this carbon with 2 alcohols, right? So which will produce a compound like this, right? Okay, so this is our T. What is the correct statement about T? It is a chiral compound. Yes, it is, right? There are how many chiral centers? 1, 2 chiral center, and then here also I'm having 1 chiral center. Total 3 chiral centers. So this is right and this is also right. This can be classified as ketal. And option D is it can be reduced. It can reduce Fehling solution. So what is the criteria to reduce Fehling solution? So to reduce Fehling solution, that must be an aldehyde, right? So what the option is saying, it is a chiral compound. It is having some chiral center, but it is not a chiral compound because of this, right? It is having symmetry. So this is not a chiral center. This is not classified as ketol, and it can't reduce Fehling solution. So answer to this question is B. This question, it is given delta G in joules. Okay, in joules, in the given transformation, that is 9x, then the value of x is, that is our question, is 5 moles of H2O is used in liquid state to liquid state, and 1 bar to 10 bar, temperature is Tk and Tk. And also they have given density of water is this much, and 1 liter per bar, which is equal to 100 joules. Okay, so let's do the calculation part. Let's see what happens. So delta G, which is equal to V delta P, right? So V value, volume, that is 5 moles, which will be 90 liters, right? So which I am writing it as 10 to the power 3 minus 3 into 9, because the pressure change, a pressure change, that is 1 bar to 10 bar, so 9. So totally it becomes 810 into 10 to the power minus 3 liter bar, right? So 1 liter bar, which is equal to 100 joules. So which makes it 81 joule. They are asking 9x. So 9 into 9. So 9 is our answer. 9 into 9, 81. So 9 is our answer. Moving on to the next question. EMF of the given galvanic cell at 25 degrees Celsius. Platinum. This is a setup. Platinum I'm having with ammonium chloride. Okay. And then acetic acid. And the EMF is 0.12 volts, then pKb of RnH2 weak base will be. So that is our question. Okay, so what is the change happening over here? So H plus of right hand side, it's becoming, I'm taking H plus of left hand side. So where the N is equal to 1, correct? So in that case, I'm substituting the values in the formula. So where I'm getting 0.12, that is given, is equal to 0.06 divided by 1. This value is given as 2.0303, RT by F value is given as 0.06, and N is equal to 1. I just substituted it. And the log value, log of H plus left hand side by H plus right hand side, I have to take. So which is, by comparing the concentration, I am getting that as, this whole value becomes 10 to the power minus 2. Okay. Then I have to find out for the second equation, that is for acetic acid. So for acetic acid, I am erasing this part low. Okay, so for acetic acid reaction, you can take the concentration 0.1. The reaction goes like this, right? Acetic acid with dissociation, it will produce acetate plus H plus. So 0.1 as a concentration is got reduced to 0.1 minus X, which will produce X and X. I'm taking like this. While substituting the concentration as X only, X square by 0.1 minus X. So while solving this, I'm getting 10 to the power minus 5. So we already found that is 10 to the power minus 2. So H plus R value becomes 10 to the power minus 3 molar. Then L value is 10 to the power minus 5, that we know. Now we are moving on to ammonia part. So what are the values we know? I'm writing it on one side. This L, that is 10 to the power minus 5. Okay. So for ammonia part, RnH3, actually amine. So reacting it with H2O to form amine and H3O plus. Again, the concentration, that is 1 molar. I'm taking that as 1 minus X after the reaction. So KH value becomes KW by KB, which is X square by 1 minus X, right? Because X and are formed. I'm writing the equation over here. RnH2 plus H3O plus, right? So let's substitute the values. So X value, which is 10 to the power 5 square, and 1 minus X, 10 to the power minus 5, which is equal to 10 to the power minus 10. Then pKb will become 10 to the power 4. Okay, Kb is 10 to the power 4. Then pKb becomes 4 now, right? Minus log of the same value, then 4. So answer to this question is 4. Then for the given compound, the total number of optically active stereoisomers is. Okay. So what are the specification mentioned over here is stereochemical configuration of this part. See, this part is fixed, but the stereochemical configuration in this part are fixed. So this is not fixed and this part is fixed. Okay. So while they are asking about the stereoisomers, just omit the unfixed part, not fixed part. Just take the fixed one. Okay, so if I am considering the fixed one, let's check out how many chiral centers here we have. So how many chiral centers? This is one chiral center, and CH2, CH I'm having, and this part will also become a chiral center, right? 2 chiral centers I have. So 2 to the power 2, which is 4. Okay. So out of these two chiral center, we have to check with the meso compounds as well. So which can form a meso compound. So total we have 4 stereoisomers, but optically active stereoisomers are only 2, because 2 are mesoforms, which is optically inactive. Right. So answer to this question, which is 2, that is also our enantiomers. Let's say this question where I have C6H11Br reacting with magnesium ether and 2-butanone, and H2O, it is forming Y. Y with H2SO4 heat, it is giving us a double bonded compound. Okay, so what can be this Y is? Okay, so why I'm just doing the retrosynthesis of this, so which can be our CH3 at that side ethyl OH H. So ma'am, how I can find which side the OH must be? Then only we have to go for X. So X, let's say I'm having C6H11 Br. Okay, C6H11 Br with 2-butanone. So 2-butanone I'm taking. 1, 2, 3, 4. 2-butanone. That is reacting with magnesium ether to form a product. Right. So magnesium ether, this will form a Grignard reagent to produce. I'm having one side ethyl, another side methyl. This part will form a OH, and which will be attached with our ring. Right. So I'm writing it in this side, having this, and methyl and bromo, this compound, this Grignard reagent is coming and attacking over here. So which will get attached? This part will become our ring, and this part will become our OH. So here I'm getting OH. OH is attached with our ethyl and methyl group. Methyl group attached to carbon. Okay. So what is the question? Identify the reactions which give the compound Y as a major product. So if you could see ethyl magnesium. So this compound, if that is getting added over here, then it would be like this, and OH will be there. Okay, let's move on to the next one. N-propyl magnesium bromide, that can't be our answer, because one side I'm having H. If I'm adding the propyl group on another side, it will not make any sense. And ethyl magnesium bromide with this compound. which will form a ethyl and methyl, which is very similar to our compound, isn't it? The first one, which is having 2 ethyl groups, and the option C, that is very similar to us, very similar to our compound. And what about option D? Option D, where again I'm having methyl group is getting added. Okay. So which makes CH3, and this side I'm having ethyl. So answer can be option C and D. Okay. Moving on to the next question. Name some of the polymers corresponding to monomers are given below. Identify and correctly matched options. Natural rubber, that is our styrene, and dacron. Don't do this mistake, which should have a terephthalic acid, so which can't be our answer. Nylon 6, caprolactam, the structure should be different, which can be our answer. And then comes Teflon, which can be our answer. And this natural rubber, which can also be our answer. So answer to this question is A and B. How many of the following groups are Lewis acids? So let's check. Lewis acid are the one which is having a vacant orbital to accommodate the incoming electrons. So as we all know, BF3, which is having a vacant orbital, BCl3 also. What about B2H6? It is a form of BH3, right? That will also have a vacant orbital. So A goes fine. What about option B? B can't be our answer. CH4 is there. And moving to option C, C can be our answer. BCl3, once again, AlCl3, B2H6. And then what about D? D, here you can see these are not having any vacant orbitals as we have for BH3 or BF3, but these are having the positive charge which can accept the electrons, right? So D can also be our answer. So answer to this question is ACD. The correct statement about silicones are: these are organosilicon polymers. The famous example of silicones are zeolite. And chain length of the polymer can be controlled by adding CH3 thrice SiCl. Copper is used as a catalyst in the preparation of CH3 twice SiCl2 from CH3Cl plus Si. So by comparing these options, you can see zeolite, which is a crystalline aluminosilicate, right? Not organosilicon polymer. It is a silicate. They are used as a catalyst, and it is not related to our silicones at all. So obviously we can omit this option. But other than this, you can see silicones or organosilicon polymers attached with the CH3 group or C2H5 groups are attached with silicon compound. And trimethyl silyl chloride, which is acting as a chain terminator in silicone polymerization. And copper is used as a catalyst. This famous reaction, which is Molar process. Okay, so answer to this question is A, C and D. So that's it for today. We have solved paper 1. Paper 2 is going to come. Please stay tuned. Let me know if you have any doubts or any concept to be cleared. Thank you.